Hi, everyone. I thought I'd create this video just to help everyone guide through the materials I'll be sending around 1 week before our next workshop on June 17th. I thought I would allow everybody to try some data wrangling using some Tidyverse packages. So today I'm going to go through a couple of the packages and show you what just the tip of the iceberg of the type of stuff that you can do in R with your data sets. So first off, let me explain what Tidyverse is. So Tidyverse is a group of packages that is actually created by the RStudio team. And they're designed with the purpose in mind of having the same syntax. So what this means is that there's similar syntaxes across all these different packages, which means that transitioning between these packages is very easy and that they're all compatible. So we've already been introduced to one of the packages in the Tidyverse, and that's ggplot2 in David's tutorial last week. And then today I'm going to introduce you guys to a couple more, including dplayer, which is a package that allows you to do data transformation, as it says here in R. So it's really good at helping do like summarization, so looking at means and standard errors and things like that. But it's also really good at like mutating and doing calculations and filtering your data. So there's a whole bunch of stuff that you can do with dplayer, and it's a very useful package. As well, we'll be touching on a little bit of what you can do with the TidyR package. This is a package that allows you to do like tidying of your data. That's why it's called TidyR. Essentially, it allows you to do things like replace NAs with different values. You can reshape your data from like with wide form to long form. As well as it helps helps describe what tibbles are, and which I'll get into later on in this video. But it's a very useful package for data tidying and QA/QC type stuff when working in R. And then the last package I'll be working on today with you guys is called ReadR. And it is a package that helps you import data. Now you can still import data using base R, like how David showed us last week, and that's perfectly fine. But today I'm going to show you potentially why you might want to and how it works well with the other packages. And then there's a bunch of other packages that are in the TidyR universe. So if I like scroll down this page, there's like per, stringer, forcats. I haven't used all of these. One that is very useful, that if you end up working with like time date data, like if you're working with hobo loggers, the looper date package is wonderful because R has a really hard time understanding date and time variables, especially when they're put together. So this just really helps simplify that, and it's been updated quite frequently. As well, another good package is R Markdown. I won't have time to go into that today, but perhaps in future sessions. So one reason I actually pulled up this page was I wanted to show you where to get these cheat sheets that go through kind of the basic functions that each of these packages serve. If you just go to rstudio.com/resources/cheat sheets, you can access the most updated cheat sheets. So they're updated quite frequently. As you can see, the ggplot one was last updated in August 2021. So it's good to refer back to this page whenever you need a new cheat sheet. And this is kind of what they look like too. So it goes through like the different like categories and the different functions, what the calls are and all that fun stuff. This will make more sense as you become more familiar with R and with the Tidyverse. Okay, so let's move on to our actual task for this week. So I decided to use some of my actual data from my master's project for us to play data wrangling with. So this is real data, and I wanted to use real data because I want to show you the messiness of real data and how using R and using these packages can really help you reproduce or produce reproducible code in a way and make it really easy for us to share our code and understand what went into running these analyses. Just to provide you a little bit of context of what this data means, it's this morphology data. So I'm just going to pull up a figure real quick. So my master's thesis was done on Chinook salmon, and I looked at the interaction of maternal stress and thermal stress on Chinook salmon morphology, their behavior, the physiology. Today, we're just going to focus on their morphology. This is a figure from a different time point than the data I'm sharing with you guys today. So it has some similar measurements as the data set we're going to see today, but not all of them. So in the data set we're going to see today, we're going to see the length measurement. So the standard length, which goes from the snoot to the caudal peduncle, the fork length, which goes from the snoot to the fork and the tail, as well as gape length, which is from the snoot to the apicular flap, eye width, which is pretty self-evident. And I believe that's it. We might have caudal fin width, but I can't remember if I actually included it in this data set or not. So that just to orientate you of the type of measurements we're taking of the fish. And what actually happened is I took pictures of the fish, and then my wonderful undergrad volunteer at the time, Chelsea Frank, who's actually doing her master's at GLIA right now at University of Windsor, actually went through all my photos and did all these measurements for me. So I am eternally thankful to her. And then just to help you understand the background of my thesis. So as I said, I was studying the interaction of maternal stress and thermal stress. My maternal stress I mimicked by dosing these fish with cortisol, which is a stress hormone. So I have two treatments of my cortisol treatment, which is like control. So they receive no cortisol treatment, and then a cortisol dose where they actually did receive a cortisol treatment of I think it was 1,000 nanograms per liter. It's funny, you end up forgetting all the details. Anyways, so, and then I took those fish and I raised them at two temperature regimes. The first being the cool temperature regime, which is outlined here in blue. That was chosen to reflect like conditions that we would see in our rivers today. And then elevated temperature of 3 degrees higher, which is supposed to reflect what we would expect in the next 50 to 100 years due to climate change. And that's kind of the basics. So let us open up our project in R script and R. So this is the folder that I have sent out. I want you guys to open up the R project first, because that will open up our studio with the correct working space. So we don't have to set our working directory because we have used this R package, just like I talked about last week. Now, first off, we're going to run this line of code, and all that does is it gets rid of anything that might be in your global environment here. It's important to do that so that way you're not accidentally calling on different analyses than what you're actually working on. It generally isn't usually a problem if you're very good at naming things differently, but sometimes you end up using the same sort of keywords all the time, or you call your data set data. So it's just really good practice to always clear out that environment before starting any work. All right, and then next we'll pull up the packages we'll be using today. If you don't have them installed already, you can run this line of code right here. I just added a hashtag so it wasn't, it was inactive as code, and you can just run that and that will install the package if you don't have it. Now I'm just going to put the hashtag or # in front of it just to make it inactive. Now, once we have them installed, we want to take them from the library, pull them off the shelf, so to speak. You can also do it, using this line of code, but you can also do it the way that David showed us last week, where you just like type it into here and then you click the box beside it. I prefer to run it in the actual code because it means that if I hand this to another person, then they know exactly what packages I use in order to run this code. It's not any guessing game, because when you tick the box over here, it's not actually recording it in our R script file. Okay, so first off, we need to import our data set. So I'm going to go through a couple of options of how to import data. So this first one here is very similar to how David did it last week, where we use this script here, read.csv, and then we're calling up the path where our data is located. So we go back to our folder here. If we click on the data folder, we can see that this data set is right here, which is perfect. All right, so we run this line of code, it comes up perfect. We can click on it over here and view it, and it is looking good. So just to orientate you guys to some of the columns here. These are like, we have our date, trial number, tank number, our photo ID, our maternal ID, so the ID of their mom, whether or not they were actually treated with cortisol, their fish number, which is something you guys don't really have to worry about, mass, and then all those morphology measurements that I showed in that one figure. Okay, perfect. It uploaded. That's great. So one thing that is important to see when uploading a data frame is looking at its actual structure and seeing that R actually read the variables or like place the variables in the correct categories. So one way of doing that is by looking at the structure, which you can do using this str call. So if we run this line and we look below, it tells us that it's a data frame that has 144 observations of 18 variables. And then we can see all our different columns. And right here is what R is telling us what it has categorized each variable as. So date, it has characterized as a character, trial number as an integer, and then all of our like length measurements and stuff as numeric. Now these all have different meanings, and I suggest when you go to actually analyze your own data to go look it up on Google. That is one thing that is amazing about R. There are so many online resources, and perhaps I'll do a tutorial sometime looking at Stack Overflow, because that is a very good resource for R coding and stats help. All right, so cool. We uploaded it using base R. How do we do it? Using ReadR, which is that package that I talked about that's part of the Tidyverse grouping. So it's very easy. It's almost exactly the same code. Instead of that dot, we use an underscore between read and .csv and CSV. So we run this code, we can see that we've imported it. So below, we see that's imported. It's telling us that some of the characteristics of the different variables. And if we run the structure, you can see that something else a little bit different has popped up. So we can see at the beginning, we see how base R is kind of categorized and treat those numbers. But the second part actually shows us how ReadR is actually reading these variables. So up here, the trial number is considered, oops, I'm trying not to highlight it. The trial number is considered numeric, but down here it's considered a double. Now, a double is still a numeric value. It just talks of, when they refer to double, they're talking about the number of spaces that are retained in memory in your actual data frame, which is something that you don't have to worry as much with the size of data set we're working today. But if you're working with a very large data set, numeric, I think, keeps up to like 16 characters, whereas if you store something as a double, it's 4 characters or something like that. I can't quite remember off the top of my head. I will look into it if that's something that you're ever worried about. And then we can see that as we go down, there is, there you have either considered a column as a double column or numeric type column or as a character. Okay, brilliant. It has also uploaded it. One thing I also want to point out is that it has actually uploaded it as a tibble. So if we see here, it says spec tibble, that's the short form for tibble, data frame. And we still have that 144 observation, like rows of 18 variables, but it does have a slightly different format. And that's where I was talking about below here, where I'm talking about the different categorizations of the variables. So what's nice about using ReadR is it's compatible with the rest of the Tidyverse packages. So sometimes you do want your your data frame to actually be a data frame. Like you don't want to import your data set as a tibble because perhaps you're using a non-Tidyverse package and it doesn't know how to read tibbles. So in that instance, you can actually, I'm skipping a little bit of code here. Sorry, guys. Down here, where instead of going through base R, because for some reason I really like using ReadR, I can just add this pipe operator and then add this line of code that says as a data frame. So if I run this, we'll actually see that this is now a data frame. So it's showing us as a data frame in the actual R. Perfect. So what's nice about tibbles is, yes, it goes along really well with the other packages in the Tidyverse, but I also find that it's really nice because it's a little bit easier to define what you want each variable category to be. And what I mean by category is like whether or not you want R to see it as numeric or character or a logical, logical being like binary variable. So in this instance here, so I'm scrolling back up after that tibble section at line 39. If I upload this data set using ReadR, I can actually say that I want maternal ID to be a character and not a double. The reason I might want that is because my maternal ID was just based off of numbers, but it could easily just have been like mom A, mom B, mom C. So really, functionally, it's acting as a character or a factor and not as numeric or a double. So by specifying this line of code where I say cold types equals columns, bracket, and then the variable that I want changed equals, I want it, I'm saying I want maternal ID to be, oops, to be character, not double. And then when, after importing that, and then I look at the structure, I can actually see that the maternal ID or the DAM ID is actually a character now instead of a column double. All right. And that's basically what I wanted to show for that. I know back there I did introduce what a pipe operator is. I don't really want to go into too much detail about that today. So I suggest checking out this YouTube video. He explains what a pipe operator is very well. It's like 4 or 5 minutes long, so worthwhile. It's basically a way that you can run multiple sort of functions on a data set without having to type it out or embed them within each other. So it just makes it a little bit cleaner and easier to read what was going on. So I used a pipe operator here, and I'll be using it a couple places down below. Okay, so now that we've played around with the different methods of importing data, oh, actually, I wanted to show you one more thing. There is a way to import data, not through code on here, but rather through the RStudio interface itself. I don't recommend this because, again, it means that if I give this code to another person, they don't know exactly where I pulled stuff from. And it's just overall more repeatable if you write it in your actual R script. But I'll show you how to do it. So I'm trying to remember code view plots session. Here it is. Okay, so you go to your files and you see your files in the folder which our project is in. So this is the main folder. I click on my data. I'm like, I want to upload that elevated data. I can click it and select import data set. Now, this is the URL of the path that the data set is sitting. And you can choose what package you would like this to run in. Where is that again? Oh, I must have updated it. Okay, so when you import using this, you're using the ReadR package, and when you upload it, it will actually upload it as whatever name you have the CSV file. So it can make really long names for coding. So you might want to go down and edit it here where it has the actual code, but all it's doing by clicking through it, it's still running the same code that you was in the R script there. It just allows you to click through it instead of having to actually type it out. All right, we're going to hit cancel because we already have it imported. Okay, so that's importing data into R. So let's move on. For our next set, I actually included the data for this project as two different data sets because I wanted to show you guys how to combine them together. So we have to upload our two separate data sets. Before we do that though, just to clean it up, I'm going to go over here, click the clearing button. This just gets rid of anything that's in my environment. I just like to keep it nice and tidy. All right, so we have the fish morphology from the elevated raised group, elevated temperature raised group, and then our cool water temperature raised group. So you can see there's a little bit more observations in our cool water data, the same amount of variables. So that's good. So when you want to combine two data sets, you can do this completing R. So in this case, I imported, or the data was inputted as two different CSV files with all the same morphology data. And because these were separate files, I actually don't have a column saying which temperature treatment it was part of, which is something that's very important if I want to combine these two together. So first off, what I'll do is I'll make a new column in each of these data sets that says what temperature treatment it is. So I'm just calling that new column or new variable temp treatment. And then I'm just saying for each of the data sets what I want that variable level to be called. So in this case, I want it to be elevated. So I click on that. And then if I look at the structure, I can see here that, yes, now we have this column called temperature treatment, and it's considered a character. And you can see that it's elevated, 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 and all. If you also want to double check too, you can click on the global environment here and view your data set here. And if we scroll to the end, we can see that the temp treatment column has been added and it is all considered elevated. Brilliant. All right, let's do that again for our cool temperature treatment. I actually am going to leave this code out of the script I send you guys because I want you guys to try to type it out yourselves. But I guess you could look at this video and cheat. So we run this and we can see again that we have this new column called temp treatment, and it just says cool, 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 cool over again. It's Jake Peralta from Brooklyn Nine-Nine. Fantastic. So again, we can click on it and go over and we can see that it has the right right treatment in the temperature treatment column. Perfect. So one thing to note, make sure these two columns are named the same thing, or else you will get error messages and these data sets will not combine together in the way that you want them to. So just make sure it's the same. Okay, so I'm actually going to pull up the dplayer cheat sheet real quick. So there is, as you can see, a lot of different things you can do with it, but what we're going to do today is look underneath this combined tables column. And what I want to do is take one data set and another data set that have the exact same columns, but different rows and bind them together. So this, we use the bind rows call. All right, so we're going to use the bind rows call, and I'm going to call the new data set morphology because it has both my elevated temperature treated group and my cool water temperature group. So what I do is I'm going to name it morph, and then I'm using the call bind rows, and then I'm taking my elevated data set and my cool data set, and that's telling that I want those two together. Now I added this pipe operator because I wanted to make sure that morph will end up as a tibble, not as a data frame. So run that. It worked. It has popped up in the environment. Brilliant. And one quick check you can always do when combining rows together is you make sure that it's like 148 plus 144 actually equals 292. Just ways that I always make sure that things are working as they should. And let's look at the structure. So yeah, we can see that there hasn't been any new columns made, that it's still 19 variables. And we see that, yeah, it seems within the parameters that we set out. Okay, so this is a real data set, and we don't actually need all these columns for what we're going to be doing in our workshop next week. So to help clean it up a little bit and make it a little bit easier for us to play with the data, I thought we could get rid of some of the columns and just keep the ones that we need. Now, just a little caveat, I wouldn't get rid of all the columns that I'm actually getting rid of if this was for an actual paper or publication, because some of the variables are very important to keep track of, but for today's sake, it does not matter. All right, so we can also do this using, this is still through dplyr. So again, if we pull up our cheat sheet, it is up here. It's the select function, which allows us just to select which columns we'd like to use. And it selects it underneath the variable itself. So I am taking the morph data set, and I want this new data set that's selected to also be called morph. So I'm basically overriding the morph data set here. If you're worried about things going wrong here, you can just add like a morph 2 here, and that way you know that this is like the smaller data set with just the selected columns. Now, there's a couple of ways to select columns in the actual script. You can do it using a colon. So here, I selected the first column, which is date, and then I put a colon and then trial number. And what I'm saying here is I want all the columns between date and trial number. There's only 2. I just wanted to show you guys how to work this. So it's fairly easy. You can also just list out the parameters that the variables that you want to keep. So in this case, I kept my maternal or DAM ID, I kept my cortisol treatment, kept my mass. And then again, I use that colon method, sorry, to keep everything between the first morphological length measurement to the last one, which was eye area. So, and then I also kept the temperature treatment column as well. So essentially I got rid of like some of the comment sections, and like there's the photo comments as well as photo ID and stuff like that, because that isn't as important for what we'll be doing in the workshop on Friday. All right, so we run this, and it's called morph 2 because I kept it there. So if we open it up, we can see that it is now just the columns that we had selected. Perfect, it's working as it should. All right, I'm just going to get rid of the 2 and rerun that, so that way the rest of my code works. So I don't know if you guys noticed, but my cortisol treatment column is just N's and C's, which makes sense to me because I was the one that like came up with this coding, like this data set. But for you know, everyone else, who knows what that means? I will tell you what it means, but we're actually going to replace the names of the levels in this variable in order for it to make more sense and in order for it to, you know, work a little bit better with our code overall. So just to let you know, N stands for no court, so it's our control treatment, and then C stands for cortisol dosed. So in order to replace those that nomenclature inside the cortisol treatment variable, I'm going to use this function under, again, this is found under D player, called mutate. And under mutate, you can do a whole bunch of different things. So if you look at this cheat sheet, here's the mutate column, but it talks about adding all these different things. And then if you go down here to the next second page, all of these different functions here can be used with the mutate function. So you can do all sorts of things using this mutate call. So I'm using mutate, and then I'm also using this code called recoding. So basically what I'm saying here is I want to mutate the cortisol treatment variable. And the way I want to mutate it is I want to recode N to mean control and C to mean cortisol dosed. Okay, so let's see if that works. So we click on morph and we can see, yes, that the N's have been replaced and with control, and the C's have been replaced with cortisol dosed. If you ever want to like play with how things are viewed in R2, you can click beside it and it starts sorting the data by the different levels of the variable. So you can see all the controls at the top and the cortisol dose ones are at the bottom. And then if you want it reversed too, you can just click it again. And then you can, oh, maybe you can't click it. Oh, usually to get it back to like neutral, you can click over here on the rows names. Okay. So brilliant. So we have imported our data. We have tidied up a little bit of the data set. We've gotten rid of a couple of the columns. We've renamed some of the levels. I think this is ready for our next steps. So just so that way we have a copy of it so we can use it for next week, we're going to export the data frame that we just created here. Now to do that, we're going to write a CSV file, and it's a very simple code here. You just write .csv, then the data set that you want to create a CSV of, the path that you want it to be saved in, and what you want its name to be called. So here I put Chinook salmon morphology underscore all temperatures .csv. You have to make sure that's there. And when we run that, we'll see it pop up in our files right here. And that is it. So if you guys have any questions before our meeting workshop, you can email me, or I can try to address them during the actual meeting. And yeah, so you guys enjoy, and hopefully you find this easy to follow along. All right. See you next Friday.